Good morning, good afternoon. Today's title will be Area of Composite Figures. Make sure you title your page. Our lesson objective for today, students will be able to find the area of composite figures. To find the area of composite figures, break the figure down into simpler, less complex shapes. Shapes like triangles, rectangles, circles, semicircles. A semicircle is a half circle, by the way. Um, and you're going to find the area of each piece, and then you are going to add all the areas together to find the total area, basically. So what I mean by that is, look at example 1. This figure is shaped like an L, right? There's no formula on the formula sheet to find the area of an L. So what we're going to do is we're going to break this figure up into 2 rectangles, and then we'll be able to use the formulas from last class to find the area of each piece and then add them together. So there's no right or wrong way to cut this. I'll show you 2 different ways you can cut this one. But the first way, I'm going to go straight down like this. So I'm going to have piece A. I'm going to label that piece A, and I'm going to label this piece B. Piece A is a rectangle, right? And we know the area for a rectangle is area equals base times height. The base of piece A is 8. If this is 8 up here, then this is also 8. So the base is 8 times the height. How high is the rectangle? It's 9. So the area is just going to basically be 8 times 9, which is 72. So are we done? No, because remember, we broke this up into 2 pieces. So we have to now find the area of piece B. Piece B right here is also a rectangle, more specifically a square. Same formula, area equals base times height. The base is 6. If the top is 6, the bottom is 6, because we learned a few weeks ago that in a quadrilateral, opposite sides are congruent. So 6 is our base. Our height right here is also 6. So the area of piece B is 6 times 6, which is 36, right? So we have 2 areas, 72 and 36. To find the area of this L-shaped figure, we now push these 2 together. 72 plus 36 is going to be 108. So the area of this L-shaped figure is 108 yards squared. Area is 2-dimensional, so the units are squared, okay? Now, like I said, there's more than one way you could have cut this. That was just the easier way, but I'm going to erase. So if you need to pause right now, pause right now. But I'm going to erase this and show you the other way you can cut this. I could go horizontally across like this. And I could say this is piece A and this is piece B. A is still a rectangle, so area is going to be base times height. If that's 8, that's 8. So the base is 8 times the height. This is where it gets difficult. It's a little more difficult this way. For the height, we need this piece, right? But we don't have that side. It's unknown. And we also don't have the side opposite it, so we don't know what that is, right? But what we do know is we do know that this entire piece from top to bottom is 9, right? And we know that this right here is 6, right? So the difference is that. What's the difference between 9 and 6? How much do you have to add to 6 to get that whole thing 9? It's 3, clearly. So if this is 3, this side is opposite, that means this is 3. This is opposite, that means that's 3. So the height of that small rectangle at the top is 3. You can kind of backtrack and figure that out. So 8 times 3 is 24. So the area of piece A is 24 if we cut it that way. Now B is also a rectangle. A equals base times height. The base of this one, we have a similar situation like we did before where we're not given the entire base, but take some of this away so it's less confusing. We are given to find this entire thing here, we can add this plus this. 8 plus 6 is 14. So the base is 14 times the height of piece B. The height right here was given 6. So we're going to do 14 times 6. I can't do that in my head. I reach for my calculator, so y'all can reach for your calculators. 14 times 6 is 84. So we have 84 and we have 24. Add them together. 84 plus 24 is still 108. So like I said, either way you cut this figure, you're going to get the same area. It's 108 yards squared. Example 2. It's already cut for us, kind of, right? So let's call this piece A, and we'll call this other one piece B. Piece A is a semicircle. It's half of a circle. But we don't have a formula for semicircles, so we're going to use the circle formula, and then we're going to cut that in half. Let's write this in the notes. Use formula for circle, and then cut answer in half. When you see a semicircle, when you see half of a circle like that, like on a basketball court, you use the formula for circle and you divide it in half because that's half of the circle. So the area for circle, the area formula for circle is A equals pi r squared. We use 3.14 for pi. And this way I was messing up last time. The radius, if the diameter of this is 10, this is not a radius, this is the diameter. Radius is only half of it. So what's the radius here? 5. So 5 squared. Type this in decimals. 3.14 times 5 squared is going to give you 78.5. So the area of piece A is 78.5. Now for piece B, B is easy, it's a rectangle. So the area of a rectangle is base times height. The base is 15, this is 15 because it's straight across, so they're congruent. 15 times the height is 10, that's 150. So now we add 78.5 with 150, and we're going to get 228.5 inches squared. That's my final answer for the composite area of the figure in example 2. Let's now look at example 3. Well, I know in this one, I'm going to want to make this a triangle right here. And then with the other two pieces, I can either cut it straight across or I can cut it going down. I'm just trying to think here. The best way, I think the best way is to go straight down. All right, so let's call this piece A. This is piece B. And that's piece C. A is a rectangle. Area for rectangle is base times height. The base of this is what? Look for the top, look for the side opposite. The base is here, opposite that is 5, so the base is 5, times the height is 10. 5 times 10 is 50. So the area of piece A is 50. Now let's find B. B is also what shape? That's a rectangle, so base times height. The base is 15. The height, we don't see it, but let me get my highlighter. If this is 10, that means this whole piece is 10 also, right? We know this is 6. So if we have already 6 of the 10 accounted for, how much more do we need to get to 10? We need 4. So that means this is 4 right here. Again, 6 plus 4 is 10. This whole thing is 10, and this whole thing is 10. That matches up. So I'm going to use 4. 15 times 4 is 60. So the area of piece B is 60. And now lastly, piece C. This one is very complex. Okay. C is a triangle. Area equals 1/2 times base times height. Area equals 1. Oh, no, it's not. Yay. At first, y'all, I thought, I saw this thing right here with the little marking, and then I know this is going to be congruent, so this is 5. And I was like, oh, man, we're going to do Pythagorean theorem. But we don't. Let me show you. So the base in this is right here, right? How am I going to find that? Well, let me highlight again. Let me switch my colors up so it's not confusing. This whole thing is 15, and this is 7. How much more do I need to get to 15? What's the difference between 15 and 7? It's 8. So that means this is 8. If this is 8, drop it down. That's 8 because opposite sides are congruent. They're the same. So my base of this triangle is 8 times my height. We already have found that earlier, right? Remember, this is 4. If this is 4, that's also 4. So my height is 4. So the area of this triangle is 1/2 times 8 times 4. Put that in decimals, you're going to get 16. So now to find the total height, I add together each of these 3 segments, each of these 3 areas into one composite area. So I'm adding together 50 plus 60 plus 16. And I get 126 inches squared. So the entire area of this weirdly shaped figure is 126 inches squared. Last one. They already cut this piece off right here. Oh, yeah, I just realized something. We gotta back up. Go back to example 2. Example 2, we had a semicircle, right? And I found the area of a circle. So we had got 78.5, but that's not the area of this. The area, 78.5, would be this whole thing right here, right? So I need to cut it in half. I forgot to do that. So 78.5 divided by 2 is going to give me, I'm using decimals. Let's see, 78.5 divided by 2 is going to give me 39.25. And then I add that to 150. Add this and add this, and it's going to give me instead 189.25. My bad. Okay, so back to this one. We already have it cut like that, and I'm going to cut this like that. This is going to be piece A. This is going to be piece B. And that's going to be piece C. A is a semicircle. This time I'm going to make sure I remember to cut it in half, okay? That's a circle-ish figure. So area equals pi times radius squared. 3.14 times, what's the radius? It's not 20. Stop using 20. 20 is the diameter. The radius is 10. Half the diameter is the radius. So 10 squared. So the area of the circle, the imaginary circle, 3.14 times 10 squared is 314. But this is a semicircle, so divide this in half. We only have half the circle on that picture. We don't have the full circle. So it's going to be 157. That's the area for section A. Now, section B is a rectangle. Area equals base times height. Area equals, do I use 32 or do I use 20? What do you think? Think about it. This is 20, right? So this is 20. 32 is this whole thing. So we're going to use 20. The height is obvious, it's 14. So 20 times 14 gives me an area of 280. And then lastly, section C is a triangle. The area of a triangle is 1/2 times base times height. The base, we have to figure it out. If that's 32 and that's 20, how much more do I need to add to 20 to get 32? You subtract 32 minus 20 to find the difference. The difference is 12. If that's 12, this is 12 because they're opposite. So my base of that triangle is 12 times the height, same height. If this is 14, this is 14 because they're opposite each other. So I'm going to use 1/2 times 12 times 14. And I get 84. So to find my final answer, I'm going to add all three of these areas together. 157 plus 280 plus 84. That's a 7. 157 plus 280 plus 84 equals 521 millimeters squared. And again, this time I remember to cut this in half. I literally just checked in my head. All right, y'all, so that's how you find composite area. Break the shape down into simpler figures that you recognize from the last lesson where we found just basic area, and then add them all up.